All right, everybody. Hang on, let me get this pesky banner out of the way. Oh boy. There we go. Hi. How is everyone? Can anyone hear me out there? Just give me a little chat if you can hear me. Okay, HTML decoder says copy. Awesome. Welcome. Hi there, Drumal. How are you today? Good to see you. While we're waiting, I wanted to send a couple links. I have a check-in, actually, from yesterday. And I also wanted to send the registration link. So make sure that you follow both of these links. First one here is the survey for our check-in for part 2. I want to know what you all thought of part 1. Give me a thumbs up in there if you felt good about that material, and a thumbs down if you didn't. And then we'll move along. Let's see what we have so far. It's like we have a few thumbs up. So it looks like we're probably gonna move on then to our next part, which is gonna be tool use. And we're also gonna review a little bit of what we did yesterday with some hierarchical emergent agent relationships. But before we do that, I wanna make sure everyone gets checked in for today's workshop. That's really important. I'll paste it over here. There's the check-in link. And you should see something like this on your screen. It's really important because, yeah, these check-ins help us know what people are interested in, what we should make more of, things like that. So we really want to know if you've attended some of these workshops. All right. So before we get further, want to actually introduce myself because I know not everyone was here for the last um, stream. So my name is Steven. I work for Major League Hacking as a coach. I've been doing this long since before there were AI agents of any kind. um, but we've always tried to bring some of the most latest technologies and exposure to those as possible. So this is just one of the newest efforts. But yeah, today's workshop is it's going to be on low-cost LLMs and agents. So in the chat, can anyone let me know if they did not see our first part? Because then I can give a little brief overview of what we did. Even while I'm waiting for that, I'm going to send 2 links to some technologies that are really what we're some of the things we're using. One of them is Ollama. So I'll send a link to that. This is one of the technologies that we used yesterday. And it's a great way to get up and running with some large language models on your local machine. So I'll actually do what I did yesterday, and I'll open up a terminal so that we can practice with Ollama. So once you have Ollama installed on your computer, you can actually use your local terminal. And one thing I'll do is Ollama serve. I think actually we already have it served up, but if it's your first time using Ollama, you'll need to get it up and running. But then you can do Ollama run, and you can run a model. So we were using the Gemma 2B model, which is a Google DeepMind based open weights model, and it's low cost. And yeah, we can just say something like, "How are you today?" And it'll tell me. Okay, so interesting. Wilson asks, is there a recording for the first part? Yes, there is. Let me send that out to all of you so that you have it. Yeah, we definitely want to give you that. Here it is. So feel free to check that out. We'd love to see you visit our YouTube website and get a sense of what is out there. But yeah, this is Ollama. So we're able to like send these prompts and let's say loop in Python. Okay, so there we go. We're able to send these prompts, and the funny thing is, it's not actually reaching out to any server. It's all local. So if you were on the airplane or you were in a place with no Wi-Fi, you could still run this Ollama model. Isn't that kind of cool? The one of the ways, oh, and you can do /by to get out of here. One of the ways that it does that is by downloading the models to your machine. So you can actually use the Ollama pull command to download a model. I already have Gemma 2B. Let's try Gemma 27B. Okay, not yet available. Gemma 7B though. Look at that, a 5 GB model. We'll let that download and play with it a little bit today. But the other technology I wanted to tell you all about is called Crew AI. And so I'm going to share that as well. And Crew AI is right here. So it's essentially a framework for having agents work together and use tools. That's really as basic as I can explain it. And we'll talk about that today. I'm going to send a link to their website in the chat. Okay. A few questions in here. I missed the previous stream. to follow through this stream, any prerequisites to have? Okay, I'll share that slide because yeah, there actually are a couple of prerequisites. So I'll show you here. And maybe we'll go through these just so that it's a little bit easier. So the first prerequisite is Python 3.9. So you need at least to have that version of Python, I believe, for Crew AI to work. Some form of Git to download the examples that I have for us today. So if you have GitHub, for example, that's going to be totally fine. And then what we'll also require for today is a basic understanding of Python programming and a basic understanding of AI and ML concepts, okay? So yeah, definitely worth reviewing some of those if you don't have those knowledges. And if you don't, it's okay because you just ask questions throughout the stream and I'm happy to help out. All right. And another question here, I'm having trouble accessing the session 1 guide for GitHub. And so I'll send the link there. I moved around a little bit some of these resources, but check out the GitHub link, Crew AI repository, and I'll show exactly what you should look at for session 1, because that was a question here. So if you click on this PDF here, you can see I've updated everything for day 2. So you click on this PDF and you'll see the slides. So this is a great way to walk through. You can get the prerequisites. You can get started here with some of the part 1 stuff. So walk through these slides, and then yeah, we'll even go through a few of these today at the beginning. So right now we're on slide number 3 here, prerequisites. Okay. So because there's quite a few of you who didn't attend last time, we'll quickly go through some of these things that we talked about last time. First thing we talked about was cloning the repository. So as I mentioned, Git is kind of important for this workshop. So if you know anything about Git, you'll one of the first things you learn about is cloning. So you can just copy essentially the codes that I have up on my GitHub and put them in your own directory. So you go into your terminal and type these commands, and then your data will be the same as mine. And then the other thing we'll do is create an active virtual environment. So this is pretty important here because we don't want to install all of the dependencies that this project relies on into your local root, because then you'll have those for every project and you might not need them for every project. So we usually create a little virtual environment, a little container like this to silo the dependencies into, so that we can run our project, but it won't interfere with anything else that's going on. Okay, so how do people feel about this idea of, this is basically, and then we'll install the dependencies using this command here, because in my GitHub repository that I have shared out, you'll see we have a requirements.txt listing all the dependencies. And Crew, I'll just point out a few of them. Crew AI is the agent software that we're using. And then we have some things like that are new actually for part 2. So we have .env. We're going to actually use the .env file this time. And then we have some other things like LangChain, which is a good way to get the Ollama models into this. So yeah, and here's the dependencies for the Flask web app, because we are going to build a web app by popular demand today. So definitely get hyped for that. But yeah, so how do people feel about these things? I mean, we have these three quick start. So we have clone the repository, make a virtual environment, install the dependencies. All right, so those are our 3 initial steps. Give me a chat if you've finished this, or you say, "Oh, this is, come on, Stephen, let's get going and and start doing some AI agent stuff." Or maybe you could say, "Slow down. I need some help with these things." Either one is totally okay. All right, so let's continue along then. And I'm going to talk about some of the other prerequisites that we'll need here. Oh, yeah, no problem. Awesome. Thanks for that, Wilson. Coming in clutch there. So, yeah, next step is to install Ollama. I already went to that resource and showed you all about that, but I'll send the link again in chat. And Ollama is really a way to get offline LLMs, like I mentioned at the beginning, if you weren't here for the beginning. And we're going to download the Gemma 2B model, which is probably going to work out for most people's systems. I think most of you will be able to handle that with your computers. And excuse me, if you can't, then just follow along with this stream and send me a message. Maybe we can find some model that's even smaller for you to work with. But Gemma 2B is about as small as they get. It's just about 1 gigabyte large. And then now we're done with our prerequisites. So we'll move on to part 2 because we already did part 1 yesterday. As Pope Fury says, already done most of the first stream prerequisites and VS Code. So that's awesome. Last time we really got up and running with agents and teams, and in this case crews, tasks and things like that. But today we're gonna start with that, and then we're gonna move on into tool use. Okay, and so and then we're actually going to build a chatbot system for us to use. Okay, so that's going to be the agenda for today. But how do people feel about Ollama? It takes a while to install Ollama, I'll just say. So definitely get on that early. All good. Okay, so let's go on to part 2 then. I'm going to move us on to part 2 here. Oh, actually, I want to go over one quick thing. Actually, I think it's fine. So we'll go on to part 2, share that with all of you. And remember, these slides are also available on the GitHub website. So if you want that link again, I'll send it in chat. Sometimes people lose the link. And specifically, we're now looking at slide 36, okay? So slide 36 is where part 2 starts. And a lot of this is going to be in the code that we have, GitHub codes. And I'm going to code it up live too for all of you to see how it works. We'll go step by step through it. But yeah, let's get started then. So the first thing we'll need to do is create a .env file. And for those of you who might not know what a .env file is, it is a way to keep some information either secret or customizable within your application. And so you might not realize this, or you might not notice this, but the .env file is not actually visible in my GitHub, or at least it shouldn't be. I hope not. Let's see. Yep, I don't see it. I don't see it anywhere. So you're going to have to create that. And I recommend creating it in the same directory that you're going to be coding in for today. So let's actually build this in our VS Code editor. I'm gonna put that up right now. Let's get it going. All right, this is from yesterday. I have this VS Code up and running. Here we are. Just a nice test directory. You can tell I've been playing with the agents. We even did some funny stuff yesterday. We said, why don't we have the writer think that it's Dora the Explorer? And that created some funny outputs. But yeah, let's go to this env file. And I'm going to delete some of these from part 1. And I'm going to put the ones for part 2. And the API key we want is the SERPer API key. And then we're going to put our SERPer API key here. And you might be asking, what is SERPer? So I'm going to send that out to all of you in the chat. It's this dev tool that I'll share with you all. Let's see here. It's basically a Google search API. Okay. So everybody can get 2,500 queries with SERPer, and you don't even need a credit card for this. So all you need is basically an email address and a password. Right? So let's try using this API. You'll want to click sign up in the top right. I'm going to click sign in though. You can see I've been playing with this today. This account that I made. Just made a test account here. And if you click on API key, you can see I have some API key here. I don't mind hiding it. I don't mind showing it because the key really doesn't have any credit card attached to it or anything. But I'll just reset it just for kicks and giggles because I want to show you all how to add this to your VS Code. Right. So just reset the key, and I'm going to paste it into my env file. All right. And let's see. So you can see how I do this. And I'm gonna actually reset the key again. But you can see this is where the API key goes. So this was my old API key. It's no longer working, but you can see it there. And I'm going to save here. And so, you could, once you run out of 2,500 requests, which is quite a few, but once you run out of that, then you're going to need to pay for the future ones. But 2,500 should be plenty for us to get through our example today. Okay, so let me give an outline of what we're going to talk about today. The basic idea is that we're going to talk through 3 things. I'm going to first discuss advanced agent development, which is going to be like how we're going to use agents together. I'm going to show you a new role, which we didn't talk about last time, called collaborator. So the collaborator can kind of, or team lead. So the team lead can kind of organize and direct the other agents from above. So think of them kind of like the conductor of the orchestra. And we're going to learn how to build some complex crews. So this is going to be where we actually use a tool. The tool in specific is search tool. And then we're going to build a real world application. So we're going to build an actual chatbot that can do some research. Okay, it's going to be really cool. So stick around. All right, the first thing we're going to do is our advanced agent patterns here. Okay, and what I want you to do is go into our file in the advanced folder called advanced agent patterns hierarchical.py. And I'm going to send a link to this in the chat as well. So this file is online, and it's kind of like an answer key for what we're doing today. So feel free to follow along with that. I'll stop for a minute. I want to see if anyone has any questions. Does anyone have any questions so far? Not yet, it seems. All right. Good. So that's good news. So let's actually go back to our code and we'll start coding this up. Okay. And so I'm going to hit the VS Code editor. And we're going to make a new file. And it's going to be called, let's just call it agent patterns. Oops, I don't want to make it in that folder. Agent patterns hierarchical.py, just so that we're all clear about what it is here today. And then I'm gonna go ahead and begin. So first thing we're gonna do is make our import statements. So we have 3 different modules from Crew AI: the agent, the crew, and the task. Does anybody from the chat remember what these do and how to use them? Just give me anything that you remember from the last stream. Well, I'll give one hint here. So agents, you can actually create an agent by not only giving it a task or like telling it what it is. So you can say, for example, you are an accountant, right? You are the editor of the magazine. You can give it a backstory too. So you can say, you always, do things in a very professional tone, and you don't inject personal opinions into what you write, things like that. And then the crew is more, actually, let's talk about the task next. So the task is then, what the agent should do. And one of the things from the task is the expected output. So let's look at some of these here. So we had a researcher, so that it has a goal. Your goal is to research, but then it could have its own backstory, like you are a researcher. And then the task has several things. So for one, it has a description. So the description is like, for example, research the impact of AI on healthcare, but then it has its expected output. So like you can restrict, you can tell about the tone of what you're looking for. You can tell about the word limits. So, we have a word limit on each of these. And then we can create the crew. So the crew then is going to be an aggregation of all of the agents and tasks for that, for this script. And then we can kick that off by actually running it and seeing what the result will be. Okay, so let's go back to our agents patterns hierarchical. The second thing we import is this LangChain community LLMs OLLAMA module. Does anybody remember what this does from part 1? No one remembers this from part 1? Well, we used this to actually communicate with our OLLAMA local server. Okay, so the OLLAMA server is running on our local machine, but we need some way to communicate from Python notebooks into that. So exactly right, JRoom, to use OLLAMA models. So we can now use this OLLAMA module to import or communicate with our OLLAMA server through Python. Right? And so then we also import some types. So I think we imported several. And then I have some logging as well because I want to log and see what's going on. So I'll import date times. And then we also import from Pydantic. Has anybody here used Pydantic before? You can actually ask Copilot to explain. Oh, that didn't really work very well. Oh well. But yeah, basically Pydantic is for validating data and generating JSON exactly for type check. So yeah, I was hoping Copilot might help me out. Let's see. We can just, what is Pydantic? So I always want to teach folks how to find this information for themselves too. So you can actually ask Copilot as well. Okay. So let's continue along. And now we can get to the actual programming. So I have some logging that we threw up there. So this is just a logger that can help us get some output if there's some kind of error or just to even see what the file is doing. But now we're going to define a class. And does anybody know what a class would be? Does anyone have any familiarity with that? So a class is basically a standard type of object that we can define and rigidly define for our code. It's something what we know as the object-oriented programming, or OOP. So if you see that terminology, now you know what that means. It means that we're looking at these hierarchical agents as a kind of object that can have its own tasks and its own attributes and things like that. Okay, so just definitely, one thing to keep in mind here as we go through. And I'm going to define a few things in this class. First one I'll talk about is what we call okay, well, some attributes here. So we have our sub agents, which is going to be the list of all of our sub agents. Okay, and remember, in this hierarchical case, we are going to have delegation. So we also are going to have our task history. Okay, that's one of the things here. And then we'll define something called a dunder method. And actually, I don't know if I want args. I don't think I have any args for it. But the dunder method is something that gets called every time we make a new object. So every time that we make a new object, a new hierarchical agent, it will define the following. So it will inherit all of its classes from these. All right. All right, so now we have a few things that our hierarchical agent can do. All right, and the first one to do that it's going to be able to do is what we call delegate a task. Okay, so this function is going to allow the hierarchical agent to delegate some of its objects, some of its tasks. Good question here. Wouldn't self be in the class object? Actually, I'm not sure how to interpret that question. Maybe you could be a little more specific there, but self here in this case refers to the hierarchical agent itself. So we always will typically add self as one of our parameters in some of these methods that we define. Oh, thanks so much. Really appreciate it. Yeah, so great. So yeah, so self is something we can use. So let's say we wanted to define an attribute, okay? And we're actually going to do that right now. So let's keep going, and maybe this will answer your question. So I'm going to define self again here. And I'm also going to ask it to look at an incoming task, which will be a task object. Okay. And we'll basically output a string. So first, I'm going to add a logger here. And the logger is just going to say that we're delegating a task. So this is totally fine, what Copilot suggested. Let me close this out so we can see a little better. And then here is where we're going to actually use self. So put your question up again, because I think other people will have this very same question. So we're going to say self.taskhistory.append. And if you remember, up here, we actually defined an attribute for these hierarchical agents called task history. And now we're saying, let's update that record and assign something to that attribute task history. So we do self.taskhistory.append, and we'll put in a little JSON object. And this actually looks pretty good, what Copilot suggested here. So we're saying, okay, look at what's happening here. We're logging that this incoming task was received and delegated by the hierarchical agent. All right. And then I have some try-catch block to put the rest of our code. Does anyone have any questions, though, first, before we go on to the meat of this, about what we're doing here? We're trying to build some kind of function that delegates our tasks for us. And yeah, we're building some logging right now for that, but we'll get going more later. All right, so let's keep going. We're going to do try catch statement. And yeah, it's fine to just have some kind of log output to tell us what happened, basically, if we had some error. And actually, maybe we'll do accept exception as E. And when you do that, it actually lets the logger know what the exact error was. So we can use E to output to the console. And then we're going to get to the meat of this. So we'll say first, relevant agents. And we're going to select agents for task. And so this will select whichever agents are necessary. All right, so let's say that the task is asking us to review a document, right? If the task is asking us to review a document, we're definitely going to want the editor agent for that, right? So that will help us get the appropriate agents for the task. And then, oh yeah, kind of confused what I did before. You find the functions. Okay, so before we started doing the functions, this part here, this is these are some attributes that we are giving to the hierarchical agents. So we want each hierarchical agent to be in charge of some subagents, and we want it to keep track of its task history so that we can have a look. So what we did here is what we can call this defining some attributes for this object. It's a really common thing to do for object-oriented programming. Is we say, okay, we have this object and it has some certain parameters to it. Like, for example, a ball might be red, it might be large, it might be made of rubber. Those are all attributes. So these are some attributes for the hierarchical agent. That's a really good question. I'm sure other people were thinking that same thing, like, what is this, you know? So good work on that. And now let's keep going. We're going to define this select agents for task function later. But let's keep going for now. So what we want to do is now in each subtask, we're going to break this into. The agents are going to have their own goals, right? So let's start by defining a couple of empty strings. The first one is going to be the aggregated subtask outputs. And this is going to be an empty list, actually. And it's going to store all of the subtask outputs, which the hierarchical agent will then interpret together. So think about this like a manager, right, at a company. The manager probably has many employees and says, I don't need to know everything you're doing. I just need to have a report at the end of the day, right, of what you did. And so that's the idea here, is that we're going to store the reports from all of our subagents. And then this string here, we're going to call it the current context for subagents. And that's going to be an empty string. And we're going to use that to get the previous context from the team. So this is kind of, I guess, like maybe a Slack channel where you're putting all of your updates so far on the project, and it has a lot of detail in it and a lot of context on the project. And we'll just pass that string into the different subagents as it gets updated. Okay, so let's continue. We're going to loop through each subagent in our relevant agents. So remember, we're going to use some kind of function to select those relevant agents and what they might be. But we're going to pass in a few things. So the first thing we'll pass in is subtask description. Okay, and so I'm going to give some description here. Let's say as the subagent dot role. So each subagent will have its own role. So as the editor, for example, your task is to, and then whatever that description is, right? And I'm actually going to say contribute to the overall goal of, right? Because, it's, let's say the editor, it's just contributing to the overall goal. You're not necessarily doing it all on your own. But then we will continue here. Focus on your area of expertise. I don't want the editor to start writing, and I don't want the researcher to start editing. So that's how we'll do that. Here is some context from your team. And I'm going to then put the current context, and then I'm going to make this a little more specific. I want to make sure that it's not the very first agent. Because if it's the first agent, then we won't have any. It'll just be an empty string. So we'll just keep that as empty. But yeah, I wonder if anyone has any questions about this. I'm actually going to combine all of these. I know in the original script I did not, but just going to combine them for ease. And then the next thing we'll do is create some kind of output. So expected output. So remember, our Crew AI system can really thrive when we give some expected output. And so I want the expected output to be a concise report from the, let's say, the editor or whatever role that you might have, the subagent might have, detailing their findings and recommendations. Sure, that sounds good, Copilot. And we'll just say related to, and then we'll add the incoming task description there. So now the subtask expected output is going to be a report, right? So each agent knows that it's supposed to create some kind of report and send that up the chain of command. There's a question here in the chat. Can you repeat the goal for delegate task? Yeah, absolutely. So think about your own work. And if you were tasked with not only doing your job or your assignment, but also with building all the infrastructure that you needed for that, or if one person was in charge of writing a whole magazine cover, it would be really difficult to put all of that information in one person's head. Just like with the models too, they have limited context, and in some circumstances, it may be better to divide and conquer some tasks. So what we're doing with this delegate task function is we're taking an incoming task, which could be kind of complicated, like write a research report. And we are delegating different parts of the task to different agents. So we have a series of agents that might be relevant. And then we tell them that their task is to contribute to the overall goal while also staying within their expertise. And so that each agent can go on and do its own thing and try to find information on its own based on its specialization in parallel, essentially. We could make it in parallel, but in this case, we're not actually. But and then report back at the end, right? And so now I will say delegated subtask. Maybe this will help to actually just specify this a little bit. Yeah, awesome, no problem. Glad it makes sense. So let's actually build a task now. So remember, this task object is actually a crew AI object, right? So it has its own description, its own agent, and its own expected output. So we'll just leave that as it is. And then we can start logging. So I'm gonna do another log here. I think I have that here, so we can have visibility. So this way we'll know like what exactly is happening in our code, and what is the hierarchical agent doing. And let's build a crew now. So we're going to build a crew. I just called it temp crew in my example, and it's going to have the sub agent, for this case, its own delegated task. I guess I broke false here. I don't know if this is really necessary. We can just keep it like that, but then it will kick itself off. Okay, so kicking off means that in the crew AI system means that it's going to really run this thing, and it's going to try to execute what we intend it to do. So once it's done with that, it's going to come up with some kind of output and save it to sub agent output. And so now I'm gonna make an append to this aggregated subtasks outputs, and it's going to be a tuple, and I'm going to put the role of the agent. So let's say this could be the editor, and then whatever it came up with. So this is now saving the report that the editor did, or the report that the researcher did. Okay, and so then I'm going to add some context as well. And it should then go ahead and keep going. Okay, a question here. Is it better to use the logging library instead of print statements? That's a good question. So honestly, I think it's okay to use print statements too. But the good thing about the logging library is that you can make custom warnings, custom log statements, and you can also output your logs to a file. So with the print statement, those will just evaporate as soon as you're done. running your codes, right? They just disappear. But with logging, we can actually create log files that stick around. And then let's say you're working on a big project and your computer crashed. Like sometimes, Google will crash or something, and they want to see why. Why did this happen? So they will look at the log. But for this topic, it's just getting used to using Logger. But good question. Yeah, keep these questions coming, everybody. I feel like today we've had more questions than we did in the first part, which is really good. So I'm glad you all are participating in that. I really appreciate it. It makes it so much more fun to hang out up here with all of you to get some inputs from you. So now we're going to aggregate the results from delegation. And so we'll use these aggregated subtask outputs. And I still have to make this function, right? These are some helper functions, what we call helper functions. Aggregate results from delegation. Select agents for tasks. Those are helper functions. But we'll get to them soon. All right. So let's actually talk about those helper functions. The first one we're going to do is make a helper function for the select agents for task. Okay. And for now, we're just going to use all of the subagents, but we could make this really complicated, and we could say, like, we could have like a whole team, like a whole company, like with some marketing department, some engineering department, and we could ask the hierarchical agent do we need marketing people for this? Do we need that? But that's kind of beyond the scope of this workshop. But for now, we'll just select all the agents to keep it simple. And then I'm going to make an aggregate results function here. And this is something we needed to do as well. And I'm going to call this actually sub task outputs to be more specific. So these are all of those reports that we mentioned, that the users are making. And we have these tuples, which we created. You might remember we had several of those tuples come in from earlier. And so if we look back at our subtask outputs, let's see if we can look back at that for a minute. Here it is. We have the role and the output that we're going to add into there. And again, this arrow at the end just shows what we expect from this function as an output. So let's continue here. We're aggregating our results. So I'm just going to make some kind of formatting for this. And so this is going to join together all of these roles and outputs into one massive report, in a nice formatted way. And yeah, I like this. I mean, maybe we'll just write contribution from there, from editor, and then I'll just say that. And maybe I'll add a logger statement here, because I would like to log this probably, so that we know when we're aggregating. And then, yeah, we'll return the aggregated results. Okay. So there's our aggregated results. And the next class we'll define, so we're done with our hierarchical agent. The next class we'll define is our research team. Okay. But before we get started on our research team, does anybody have any questions about our hierarchical agent that we just built? So the hierarchical agent, the logic of it is, we have everything that a normal agent would have. So the super is inheriting the class agent. But we're also going to have some additional abilities. And in particular, it's going to be allowed to delegate tasks, ask for reports, and get those back and really aggregate them into a single file. So yeah, does anybody have any questions about the hierarchical agent? while you come up with those, I'm going to take a quick drink of water. All right, back here. And it doesn't seem like any of you had a question, so we're going to continue along. Can you repeat how an agent is chosen and when? So right now, this is choosing every agent. You can see it's just choosing every agent. But we could build out this logic here and have it choose selectively. But it's kind of hard to do that because, yeah, then we would rely on the model's judgment of what subagents it needs. And we probably just want to pass in a list ourselves of which agents we want to choose. And we can also realize that the model will aggregate the reports from every agent. So there might be some cases where it doesn't end up using the information from one of the agents. But yeah, right now we're just using all agents. So good question for that. All right, let's continue along to our research team. So I'm going to start by having a dunder method, which is an init method, which will just kind of set up everything. And I'm assigning it a few attributes. So the first attribute is the topic, so the topic of this research, and then some agents function here and some setup tasks function. So each of these research teams will have a different way of doing this. And so now I'm going to set up the hierarchical agent structure. So we'll first call our OLLAMA LLM. Okay. I guess I used OLLAMA. I guess I forgot to write OLLAMA LLM here. Should really say OLLAMA LLM up there at the top. So make sure you've got that right. And then inside of it, we're going to put our Gemma 2B model. So we just write model equals OLLAMA Gemma 2B. Okay, so remember, this is a local model, so it's basically free for us to run as long as we keep it on our local laptops, our computers. I mean, it does take a little bit of electricity, but essentially nothing. And then we have a few different things to talk about. So the first thing is we'll have a researcher, which is not a hierarchical agent, it's just an agent. So I should get rid of this. And so this is fine for the researcher, I think, just having some goal in mind and some backstory here. And then another thing we'll do is self.analyst. So here we have some research findings and some key insights. And then we'll have a writer. So that's kind of cool. I'm not going to do the Dora Explorer thing again. Oh my gosh. But this is such a funny backstory. Oh my gosh. We did some wild stuff last time. We'll just keep experienced content writer. And then maybe an editor. I guess we actually don't in my example, I don't have an editor, so maybe we'll just keep that out to not confuse people. But you can put as many agents as you want, as many sub-agents as you want. But now I'm going to move on, and I'm going to actually create a team lead. Okay, and so this is our hierarchical agent. So this team lead is going to have access to everything, all of the mini reports from the other agents. And so has a nice goal, oversee the research process, yeah. Yeah, and I like this too. Actually, I don't know if I like this backstory that Copilot wrote. You're the team lead. Your job is to coordinate. All right, so I like that a little bit better. And there's a suggestion too in the answer key as to what you should do. And instead of verbose here, I actually should write subagents. Okay, so this is the answer to Uma Redondo, your question. How do you choose the subagents? It happens right here. So for this task, let's say we want to have each of the subagents, all of them. Okay, so this is what would get chosen, this list here. Okay, so it's kind of hard coded, but it would be totally possible to like make some kind of logic where we ask what kinds of agents should be chosen. That can be an interesting thing for us to do if we have extra time. But the next thing to do is set up the tasks. And so we have our researcher, our analyzer, our writer. But actually, this is not what I want. You always have to worry about AI if it's going to give you something you don't want. What I want instead is I want to list the different tasks based on their topic. So we might have several things to research. So here we'll say the description is going to be coordinate the full research process on the topic, self.topic. Okay, maybe I'll give it some other things to say. I'll say like start by initiating detailed research, then analysis, then final report writing. Awesome. Okay, so we have a description and we'll get an agent too. So we're going to give the team lead this job. And then an expected output, comprehensive report, including the research findings, analysis, and a well-written article. Yeah, that's pretty good. I'll keep that. Okay. So another function we'll make called execute research. And here we want to have the lead crew, which is going to have the team lead in it with all the tasks. And then let's keep the results of what we're doing. So with our logger, we can do this. So let's use our logger info starting the research process. That's pretty good. And then we're going to keep our results in a list. And we're going to say for task or team lead in self.task. These are each of the tasks that the team lead has. I like this log statement that they wrote here. And we're going to do try final task result self.teamlead.delegate task for team lead, and then some results. And we have some exception too, just in case we run into any errors. We might have an error connecting to the model or an error delegating the task somehow. So we'll have that, and then we'll return the results. Okay, and so the next step here is to make our main function so that we can get things rolling. And we'll just have a team, a new research team. And let's just say the topic is going to be AI in healthcare. Okay, so all we're going to tell it is AI in healthcare. That's it. And then the results will just save the results of the execute research method. And so then we have for each task description, result content. This is something from the answer key here, just showing what's happening in each task. Okay. And so yeah, we can just print those out. And then I want to print out the task history from the team lead. So this will be interesting, I think, for us to look at. So we want to see if we're looking at the team lead, which is this has attribute feature here. And that exists, that there is some task history, because it could just be the beginning of the, it could just be that nothing happened. We'll say for every entry in these tasks, we'll just print out the following. So we'll say task delegated. We'll say it's status. And yeah, that's fine for now. I don't really want to get too far into it. But let's just keep going for that. No task history. And so now we can try running our function. So this is just a little way to log what's happening, so we have some visibility on that. And let's try it now. Let's actually try running this and see what we get. So we can do Python agent patterns hierarchical. Oops. Okay, little error here. Let's see if we can fix that. I think it's due to the fact I said from. Oh, I said, yeah, I know what it is. Okay. It seems like Copilot found something else too, though. All right, I don't like this at all. Let's just fix the issue. So from datetime, import datetime. We're also probably going to need to activate. I'm realizing I have this this environment that works for this. Oh boy, there it is. All right, I'm sure that I'm missing some kind of comma here somewhere. So let's have a look at that. All right, this looks more promising. Okay, still an issue here. I think I did the import wrong here for this part. This is just part of the process as you find all these problems with your code. But it should hopefully work soon. Okay. No tuple, huh? Maybe I forgot to define a tuple. Maybe I can just do that, I think. See if that works. Check this too. This is happening down here, I think. Got an unexpected argument role. So maybe I forgot to define role somewhere. I thought it should have it though, because it has all the attributes of an agent. It's a little strange. I'm not sure why that didn't work actually, but let's just see what we got. Okay, I don't see why this is necessary, frankly, but okay, I guess we'll try it out. Now that's very strange. Let's see here. What did we get wrong? Does anybody see an issue with this? Oh, hey, what's up? How's it going? Thanks for joining. Having a little debug problem here. Let me see if I just literally copy the correct code, which is on the answer key. I'm sure there's some issue somewhere that will just be like really difficult to figure out. See if that works. Okay, so that worked. I just basically took it from the answer key. But let's have a look at this output because it's really interesting. So we gave this team a task. The task was to look at AI in education and basically research that, right? So first we told it just AI in education, and let me zoom in here a little bit, so I can see a little better, read a little better. Okay, so we had the team lead manage the process, and the research team assigned a high-level task to the team lead, coordinate the full research process. Okay, and so it selected the following subagents: researcher, analyst, and writer, because we told it to do that. So it's not dynamically doing that right now, but we basically told it, hey, we want researcher, analyst, and writer. And so it delegated to the researcher. As the researcher, your specific task is to contribute to this goal, focus on your area of expertise, no context yet. And so Olama came through, and the Gemma 2B model did that. Now the analyst has all of this context, right? It has its own goal, and it has its own thoughts too from the researcher. So it knows everything that the researcher sent, and it knows what it's supposed to do too. So now we'll go to the last one here, which is the writer. Okay, so the writer has both the output from the researcher and the output from the analyst. Okay, and so with all this information, then the team lead is going to aggregate the results from the subagents. So it's supposed to coordinate this and then do a final report. So here's the contributions from each person or each subagent. So we have the contribution from researcher here, contribution from the analyst, and then the contribution from the writer. And so now the full research process is done. Does anybody have any questions about that? You have an architecture diagram for this. Oh, that would have been a great thing to put up. No, actually I don't, but let's try to build one. So it's a really good idea. So here's our slides. So we can say that we get a topic and just build a really simple diagram to keep things simple. So we'll say that we get some kind of topic come in. And the topic is sent to the research team. Oops, I want to make that a little bit nicer. Okay, and then the research team has several agents in it. So inside the research team, we have, let's use rounded for agents. So these are all agents. So we have a team lead, which is a hierarchical agent. And then maybe I'll use like several other circles maybe for different, for the other agents. So this is a researcher. And we have a writer. And we have a analyst. Make this a little bigger so you can see that. Otherwise you can't see it. All right, so these are our three agents here. So these are agents. And this is our hierarchical agent. Okay. And so the task comes into the team lead. And what comes into the team lead? I'll tell you, it's several things. So what comes into the team lead is the description of the task, the backstory, and also any kind of expected output. And then the team lead sends this along into a loop here, into like kind of like a train of thought, right? So the first person that it sends it to is here, right? And then it goes from the researcher to the writer. So it's delegating the task. And then here it's delegated task plus context. Okay. So it's sending delegated task plus context to the writer. And then it's doing the same thing here. It's sending more delegated task plus the context from the writer to the analyst. And then finally, when the analyst is done with it, or actually I guess it goes from the researcher to the analyst first, and then it goes to the writer. But then once the writer's done with it, it actually sends back the data back to the team lead. And so then the team lead will output the final answer. About the final report, I want to kind of change this shape because it's not really a, well, I guess it's fine this way. So yeah, hopefully that is a little bit easier to understand. And yeah, Willie, we could definitely send a link. Actually, why don't I just share the link with all of you now so you can have it. And then I'm also going to upload the version of these slides which contains the this nice diagram as well. Oh, shoot. So here is the diagram. All right, so the team lead delegates the task. It goes along in a chain from the researcher to the analyst to the writer. Everybody is getting some context on that, as well as their own task of what they're supposed to do. And then finally, we get a final report at the end from the team lead. So the team lead's sort of waiting for everybody to do their jobs, and then it gets the final task. Does that make sense to everybody? Does everybody kind of understand what that is? So the writer is writing the report in sections and looping to complete those one by one. Well, yeah, so what's happening is the sections are completed one by one. Yeah, so you could even design a team where each team is responsible for a different paragraph or a different part of a blog post, for example. The idea is to really control strictly what outputs you're getting so that you can get outputs from a researcher who has a specific job, an analyst, a writer, and so on. And so, yeah, that's sort of the idea behind this team, is to complete each section one by one. Hi there, travel enthusiasts. Good to see you. All right, so why don't we continue along then so that we can get to some of our tool use, okay? So we're not, these agents, remind you, none of these agents are using tools. They're really just talking to each other and coming up with random stuff. So now we're going to use a real tool, okay? And this is where we get to SERP search. So let's send that along to all of you. I'm going to send you the link to this code for SERP search. It's about using a real tool here. So yeah, the idea is going to be for us to load up a environmental variable. And we're going to use that to trigger any calls to our Google search tool. And then the researcher is going to summarize what it finds, okay? So this is just a really simple example, but it'll be really illustrative. So I'm going to open up my VS Code again so we can get started. Here we are back in VS Code. we're going to put down our hierarchical agents for a minute. And we're going to do tool use. Okay, so I'm going to do all my imports. And one of the imports we'll do is from the Crew AI tools. We have Serper Dev tool. Okay, so this is what we can use to get our dev server, our dev tool. And I actually want to, I made a little adaptation to this class, this dev tool, because I want to be able to see what we're actually searching. Because I realized in the Crew AI framework, we can't actually see what's being searched. So yeah, let's look at that. But first, I want to just write the following: load.env, okay? And so what this does is it loads the API key from the env. And then I'm going to make this class that I was telling you about. I called it debug Serper Dev tool. And it's literally just the Serper Dev tool. But when it gets run, I wrote actually run. Just has the args and the quargs. But it literally just inherits everything from super, but it prints out some outputs. Okay, so this was just so I could see what was being written. And I thought you all might be interested too, to see that too. So now the dev tool will actually print out to a little log that we can look at. Okay, and so let's keep going. So there's an argument here called number of results equals 3. And so we can just now retrieve the top 3 searches. And the question is, does Gemma 2B support tool use? Well, not really, but we can make a workaround to that to still get to use our tools. So we'll do that here. We're trying to keep things low cost, aka free. So yeah, but it'll be interesting how you'll see how we do our little researcher model. So okay, the next step is to get our Ollama LLM. So we'll just get Gemma 2B, and we can set the 0.3 and the top percentile. So what this is doing is calculating the past 6 months of data. And now we'll create a researcher, okay? And this researcher is going to use that idea to go ahead and execute it. So it'll have some role, some goal, some backstory, things like that, and access to a tool and the LLM there too. Yeah, it's a good idea, actually, eTurn Viking. If you want the LLM to be better at using tools, you could definitely try some of these ideas. Yeah, well, although those are not available locally either. So the idea here was to kind of try to keep things locally on our computer. But you could definitely use some of those tools. If you have a really good computer, maybe you could use 2.0 Flash. I don't think you could run Gemini on your computer, but you could definitely use Google's plans, their free plan. Okay, so let's keep going then, and we're gonna now have this goal, which is going to be a search and summarize. This is going to be the task that we create here. So it's going to have this. I'm just going to copy this from the answer key that we have. Just basically saying, use the search and summarize. And this is the expected output here. Okay, so that kind of wraps it up for our task, and now it's on to our crew. So our crew will have some agents, in this case just the one agent, the researcher, and just the one task. And then our goal will be to essentially call this out and see what we get. So why don't we try going through and kicking this off. Okay, I think I need to indent some of this stuff because we wrote our class, but then we didn't indent anything else. Oh yeah, no worries, E-Turn Viking. I think that's a really good idea. Maybe we can try that for another workshop, where we build our own like deep research agent. I think that would be really fun to do. So, no, those are really good suggestions. Okay, so let's try this then. Oh, I hate it when it does that. Okay, I most definitely did forget a comma somewhere. Classic. Classic, classic, classic. Okay, sometimes it tells me to pass Olama / Gemma2b. Not sure why. Okay. Dang, we were getting this error earlier, actually. Try my trick of replacing my live code with what I had before. Added colon at the end. Okay, that could be. But maybe we'll move on to our, should be Gemma 2b, not 2b colon. Oh, okay. Maybe that's what it is. Yeah. Oh, you know why? Because I forgot to change my my API key. Okay, so always remember to put a real API key in, or nobody, or it won't work. Just so everybody knows. Thanks for that comment there, Etern Viking, because without that comment, I think I probably would not have figured this out at all. It's not paid. No, it's free for the first 2,500 requests. You could build your own through Beautiful Soup, some kind of web scraper, but yeah, you can see this is the result. So we got some search parameters. We searched the internet to get these. And then we get some summarization of the top 3 search results here. So you can see it's using those. Oh, yeah, that's okay. Doesn't matter. It's a free service, but yeah, it is exposed. Okay, so let's continue along with the next ones here. So we have uh, the goal of creating a little chatbot that we can interact with, and so it's fine. I'll just Google. Yeah, yeah, yeah. If anyone wants to take in 2,000 Google searches, they can. Okay, so anyway, let's keep working because we have the goal of getting our chatbot working, and I'll send a link to that in the chat. Maybe you all can try it out for yourselves. Okay. But I'm gonna open this up for us to have a look at because we're running a little bit low on time, and also the goal is not to create some kind of the goal is not really to create a like it's the goal is not to create some kind of front end website. So I'm just going to open it up for now for us to look at. Okay, so here we have essentially a Flask application, a really simple one that has all the stuff we just wrote, right? So it has this little Google searcher, and then it can read those articles and tell us about what it found on its Google search. And it also has a little chatbot interface. So you can find this at the GitHub website that I sent over. And yeah, let's start a terminal here. So we're gonna say first I have a little environment where I have all this stuff installed. So that you might need to install for yourself, but I think we should have all the dependencies we need from the intro to this workshop. But looks like our API key's loaded. Our local host too. And I'm going to try to open this up for all of you. Hopefully it works. Interesting comment. I was up to see how A2A can be used in these deep research projects. Created one using LangGraph, but A2A seems fascinating. Yeah, that could be. Yeah, I mean, it is definitely the novelty factor. I feel like a lot of these new things is kind of trying to figure out like what can we do with these, because a lot of people, a lot of the times we don't even really know what's possible these days. So that's kind of part of the goal too. But let's try to enter a research query. So what are the best restaurants in Los Angeles? Let's try this. It's where I live, is in Los Angeles, California. Hopefully it doesn't break. That would suck. Okay, so some ideas here. Some different articles we can check out that Gemma has nicely summarized for us. So we don't have to see any ads, any sponsored ads on the Google homepage. And if we want to see, like timeout, for example, we can see the link is posted here. So these are our results from our Google search. So we could have a look at that. So it's a very rudimentary researcher. And I definitely encourage you all to play with this. You could improve on this by adding more, have it, click on some of these links, scrape them maybe, and get some more information, and create your own little deep researcher. But for now, we'll just keep it at this. But yeah, as Etern Viking said, the possibilities are endless for a lot of these. So definitely get on your computer and start playing around and see what you can learn. All right, everybody. So that pretty much ends our workshop today. We were able to learn about hierarchical agents, where we take the agents and we delegate them into different tasks. And then we also played around with some really low-cost LLMs and something you could even run on your laptop. And so try this out with some other open source models. There's even some really good ones. There's now Gemma 27 billion parameter model, I think, which is comparable to DeepSeek R1 in some ways. So that's what they claim. So try it out for yourself and see what you can get. But yeah, thanks so much, everybody. Glad you enjoyed the stream, Etern Viking. Yeah, me too. I don't have a good enough computer for that, but yeah, it's pretty cool stuff. So everybody, thanks again for coming. It was a real pleasure to have you all here. I got so many questions, so many feedbacks and interests. So I'm glad we were able to do it all together. So have a good one, everyone. Oh, I'll just say one more thing. I got to shout out our next stream, which is going to be a Tetris mini event with Alberto and Varshni. So check out the Tetris mini event too. See you later.